Recall that in an earlier lesson, we looked at three different expressions that we could be given, and about the units and the meaning that went along with those. And in this lesson, we're going to dive more into how to write proper units and how to interpret the things that we're finding, especially when we're dealing with derivatives, whereas up until now, we've mainly been dealing with taking integrals. So this is the table that we already have. I'm just posting it back in here so we can refer to. Let's look at a problem like this. So the table below gives the rate at which oil is leaking from a pipe in barrels per minute, times in minutes. The rate is in barrels per minute. Actually, I'm just going to mark this as R of T. Estimate R prime of 7 and interpret it using correct units. So this is the derivative. This is the slope of the tangent line. And the trouble we have is that we don't actually have any information, much less a curve, for what's happening at time t equals 7. So our best guess for the slope of the tangent line at a point is the slope of the secant line between two nearby points. Remember, a secant line is just a line between 2 points, whereas the tangent line is tangent at a single point. So 7 would be right here, so between 5, 4 and 10, 9. Okay. So R prime of 7 is approximately equal to y2 minus y1 over x2 minus x1. So let's do 9 minus 4 over 10 minus 5. If you go the other way, you'll still get the same answer if you're letting this be the second point and this be the first point. But either way, 9 minus 4 is 5, and 10 minus 5 is 5, so that's 1. That number is easy enough, but now we have to figure out what the units are. So one of the things to notice is that up here, R prime of t, the units are always R of t divided by t. So this is going to be barrels per minute or 1 barrel per minute squared. And let's just note this is R of t divided by t. And now we need to interpret what this is. So what we're saying that this is, so derivative is always the rate of change. It can get a little bit tricky because we already have a rate, but we know that R of t is the rate at which oil is leaking. So we can just summarize that, and we can say leak rate R prime is always the rate of change of whatever R of t is. So this right here is R of t. So in front of that, we're going to put the rate of change of the, okay, I could write that a little more neatly, couldn't I? Give myself a little more space. I could also show you what I'm doing. The rate of change of the leak rate at time t equals 7 minutes in barrels per minute squared. So that is the interpretation. using correct units. We start off by putting in r of t, whatever that is. In front of it, put the rate of change of the after when it happens and the units. So rate of change of r of t time and units. In a similar problem, let's say that we're asked for estimate the rate of change of the leak rate at time t equals 13 minutes. So the key things to interpret here, whenever you see the phrase rate of change, this means derivative. Leak rate, we have to look back at the original problem, the rate at which oil is leaking, so that's r of t. And then we're told at time t equals 13 minutes. So when we go to set that up, this means that what this is saying is it's saying find the derivative of r at time t equals 13. That's all this is saying. So estimate r prime of 13, and again, just like the previous problem, we don't have any actual data for 13, so we're going to use the secant line between two nearby points. So let's see, y2 is 16, y1 is 9, x2 is 15, and 10, and I'll just notate where that came from. This is a 16. So between this one and this one, let's make sure I set that up. Y minus y over x minus x. Okay. (16 minus 9 is 7 fifths, or approximately 1.4. And again, we have to figure out what the units are. So r prime is going to be r units divided by t units. So again, r units, barrels per minute, t is in minutes. And once again, this is r of t units divided by t units. Because we know that a derivative slope of a line is change in y divided by change in x. Y is measured in barrels per minute, x is measured in minutes.